Good evening. This is Dr. Eidelberg, and today's presentation is finite element analysis, strength of materials of plate stiffening. The lab assignment will start by initiating a new inventor IPT file. We will import a plate from a given file. We'll then assign mild steel material. We'll define the mounting boundary condition, which will be fixed at 2 points. We'll define 2 loads of 1,000 Newton each. We'll show the finite element discretization. We'll run an analysis, and then we will record the maximum von Mises stress, maximum deflection, and minimum safety factor. We'll then attempt to stiffen the plate with the central rib, which has full length at given dimensions, and we'll repeat the recording of these variables. And finally, we'll stiffen the plate with additional elevated mounting seat with given dimensions, and we'll check the results again. We will then submit a report, include the screenshots of the result, and we will discuss the conclusions. The original plate looks like shown over here on the screen. There are 2 bolt locations where the load is going to be applied, and there are 2 bolt locations where the plate support is going to be located. We will then apply the finite element analysis with these loads, and we could see the areas of stress concentration and the resulting variables such as the stress as was shown here, as well as the maximum deflection and the safety factor. This shows us the stiffening rib, and again we see the results with the scale on the side, and we could compare it to the original one. Finally, we will add the beefed up sheet for the mounting location of the plate, and we will compare the result. The results can be shown in Autodesk report, and this is just a portion of it, and could be used for the conclusion. In the conclusion, we like to see what is it that we learn in this lab. What can we conclude about the process of design optimization, and how would we validate the correctness of these results? Let's take a quick look at some of the processes that we use here. We come in here to the Autodesk Inventor, we upload it, and we should have that file stored on your system, so you can easily reference it. We then generate a new part, and we will use over here the millimeter notation. The part will start as we come into the main screen. We will go over here and open an existing file, and the existing file will be given to you, and you could upload it to your desktop, and this is where I loaded it, and you see it over here, and then you could click OK, and yes, and here's the part. So once we have the part, we could apply the loading condition at the two bolt location here and the supported two bolt location here. We start the stress analysis and we create a new study. We then take the first area where we have over here material, and the material, if you double click on that, we see that it's already shown as mild steel, which we could accept. Then for the constraints, we double click on the constraints, we select this area, and we want that to be fixed. We specify the location here, and you see that over here we see the indication of the constraint, and we apply it. We then take a new location, which is here, and then we also apply that point as a constraint. So now we have the two constraints, and we like to apply the load. So we come in over here to the load, and we click a force, and we want to give the force some direction. So the direction is going to be in a z direction, and we specify that as minus 1,000 newtons. So we put here 1,000 newtons, and then we indicate the location, and we see it over here. Then we can also indicate location over here, and we apply both of them. So now we have the two loads. We then click on a mesh, and we generate the mesh view so we can see how it is being done. And then once we have that, we can go ahead and do the analysis. We can simulate that. Everything looks good, so we run it. And once the system is completed, we see over here the stresses, and we see the deformation. So this would complete the first phase. Then we would like to finish it and come back over here and generate a new design, and then we could add the stiffener as shown before. One thing that we should note is that when we complete all the analysis, then we could actually have a report over here, and this is the report. We click on that, and then we could generate the report. The system will go through all the results, including the reactions, and you could use that when it comes to write the conclusion. This concludes our description of the lab report, and you could follow these instructions to do it in your experiment. Thank you.